Hello, bachcho. Welcome back. So today we are going to tackle a topic that I know looks a bit scary at first, direction cosines and direction ratios. But trust me, by the end of this session, you'll feel like it's as easy as scrolling through your Instagram feed. Ready? Let's get started.
Okay, so let's start with a little thought experiment. If you're on a flat map, giving directions is easy, right? Go straight, then take a left. Simple. But what if you're in a game, say BGMI, and you spot an enemy on the third floor of a building across the map? You can't just shout, "He's over there." You need to be super precise about the direction, not just left or right, but up or down too. How do you do that? Well, that's exactly the problem 3D geometry solves for us.
All right, so to solve this very problem, mathematicians came up with a really neat official system. Think of it as the official rulebook for giving directions in three-dimensional space. And the star player in this rulebook is a concept called direction cosines. Let's break it down.
Now, I know what you're thinking. Direction cosines sounds very heavy, very complicated, but actually, it's super simple. All it means is this. You take a line in space, and you just measure the angle it makes with the positive x-axis, the positive y-axis, and the positive z-axis. We call these angles alpha, beta, and gamma. And then, you just find the cosine of each of those angles. That's it. We give them simple nicknames, L, M, and N. So L is just cos alpha, M is cos beta, and N is cos gamma. Simple, na?
Here's a trick so you never ever forget this. Think of direction cosines as a line's official Instagram profile picture. It's DP. You know how you choose that one perfect photo? The one with the best lighting, the best angle? It's your one official representation. That's exactly what direction cosines are for a line. It's the line's one unique, perfect, official direction.
And every official profile picture has a rule, right? Well, direction cosines have a golden rule, and this is super important, bachcho. Mark this down. If you take your L, M, and N, square each of them, and add them all up, the answer is always, and I mean always, going to be 1. It's a pakka check. If you calculate and the sum isn't 1, then something is gadbad. They are not direction cosines.
Okay, so that's the official DP. It's perfect. But you know, for everyday calculations and solving problems, we sometimes need something a little more casual, a bit more relaxed. So let's talk about the casual version, which we call direction ratios. So what are these direction ratios? They're way more chill. They're just any three numbers, we can call them A, B, and C, that are proportional to the official direction cosines. That means they point in the exact same direction, but they aren't standardized. They can be twice as big, half as big, whatever, as long as the proportion is the same.
Let's go back to our Instagram analogy. If direction cosines are your one official DP, then direction ratios are like all those photos your friends tag you in. You know how it is, nah? There are hundreds of them. Some are blurry, some are zoomed in, some are from a weird angle, some are group photos, but they're all showing you. In the same way, a line can have infinite sets of direction ratios, but they all represent the same direction.
So this slide makes the difference crystal clear. Direction cosines, the official DP, are unique and must follow that golden rule. L squared plus M squared plus N squared equals 1. But direction ratios, the casual tagged photos, are not unique. There are infinite sets, and they don't have to follow any special rule. They just need to be proportional.
Now, for what is probably the most important skill in this whole topic, bachchu, this is the kind of thing that always comes up in board exams. How do we take any of those random casual tagged photos and turn it into that one perfect official DP? In other words, how do we convert direction ratios into direction cosines? Don't worry, there's a super simple edit profile function for this.
It's literally a 3-step recipe, as easy as making Maggi noodles. Step 1, you take your direction ratios, your A, B, and C. Step 2, you calculate their magnitude. Now that formula looks a bit scary, but it's just the square root of A squared plus B squared plus C squared. And finally, step 3, you divide each of your numbers, A, B, and C, by that magnitude you just found. This special step has a cool name. It's called normalization. And that's it. You've just turned a casual photo into an official DP.
Let's do a real example. This is a very common type of question from your NCRT book. Suppose the direction ratios are 2, -1, and -2. Okay, step 1 is done. Step 2, find the magnitude. So we take the square root of 2 squared plus -1 squared plus -2 squared. That gives us the square root of 4 plus 1 plus 4, which is the square root of 9, which is just 3. Easy! Final step, divide each of the DRs by 3. So our official direction cosines are 2 by 3, -1 by 3, and -2 by 3. See? It's that simple.
Okay, listen up, because this is a point where a lot of students get confused. What if the question doesn't give you the direction ratios directly? What if it just gives you 2 points in space? No tension. It's actually even easier. All you have to do is find the direction ratios yourself first. And how do you do that? You just subtract the coordinates. x2 minus x1, y2 minus y1, and z2 minus z1. The 3 numbers you get are your direction ratios. After that, you just follow the same Maggie recipe as before.
Let's solve another NCRT example together. We've got 2 points, P and Q. First step, find the DRs. So we do 1 minus -2, which is 3. Then 2 minus 4, which is -2. And 3 minus -5, which is 8. Great! Our DRs are 3, -2, 8. Next, we find the magnitude. Square root of 3 squared plus -2 squared plus 8 squared. That's root of 9 plus 4 plus 64, which is root 77. And the final step? Just divide each DR by root 77. There you have it, our official direction cosines. You're all getting so good at this.
So right about now, you're probably thinking, okay, sir, I get the math, but where would I ever use this stuff? That's a great question. Let's look at a really practical application. Checking if your friends are standing in a perfectly straight line. You know, in math, we have a fancy word for this. We call it being collinear.
Imagine you're playing a game, maybe Valorant, and you and your 2 teammates want to line up a perfect combo shot through a smoke grenade. For that to work, all 3 of you have to be in a perfectly straight line. How does the game's code check that instantly? It's simple, really. It just checks if the direction from player A to player B is exactly the same as the direction from player B to player C. So, the big question is, how do we check if those 2 directions are identical? Do we have to go through all the trouble of finding the official direction cosines for both?
And the answer is no. We have a shortcut. We don't even need the official DP for this. We can just use the casual, tagged photos. All we need to do is check if their direction ratios are proportional. If the ratios are proportional, it means the lines are parallel or on top of each other, which means the direction is the same.
Let's see this in action with points A, B, and C. First, let's find the direction ratios for the line going from A to B. We subtract the coordinates and we get -3, -5, -3. Okay, now let's find the DRs for the line from B to C. We subtract again and get 6, 10, 6. Now, at first glance, these look different, right? But wait a minute, look closely. If you take the second set, 6, 10, 6, and divide every number by 2, what do you get? You get 3, 5, 3. And if you take the first set, -3, -5, -3, and multiply by -1, you also get 3, 5, 3. They are proportional, which means the points are perfectly lined up. They are collinear. Combo shot successful.
Whew, that was a lot. But you guys did an amazing job keeping up. Let's just do a super quick recap of everything we learned so it stays locked in your brain.
So, remember this. Direction cosines are the unique official DP, and they have that golden rule, L squared plus M squared plus N squared equals 1. Direction ratios are the unlimited tagged photos. They just have to be proportional. The number 1 skill you need is converting the tagged photos to the DP. That's normalization. And finally, to see if your friends are lined up for that combo shot, you just check if their direction ratios are proportional. That's the whole story about Joe.
See? I told you it was easier than it looks. 3D geometry isn't scary. It's just a set of simple rules and fun analogies. You learned a very powerful concept today, and I'm sure you can master it. You've totally got this.
And before you go, I'll leave you with one final thought. We've now figured out how to give the direction part of a 3D GPS. But just like on Google Maps, a direction isn't enough, is it? You also need a starting point. So the question is, how do we write the full address of a line in 3D space? We'll find out the answer to that in our next explainer when we talk about the equation of a line. I'll see you there, Butcho.